Hello, and welcome to Technically Speaking, where scientists and engineers come together to chat about a common interest, share knowledge, and satisfy some curiosity. I'm Laura, and I'm joined by Rwayda and Antonia to talk about energy efficient buildings and how this might differ around the world because different climates obviously have different requirements. I'm interested in this because there isn't really one size fits all solution given the different climates and different construction materials, and I've heard of some really interesting ideas that make use of natural processes that I think just sounds like ideal. Now, Rwayda, you're a civil engineer, so I guess you'd know a fair bit about this, but is that right?
Yes, I think the main thing is whatever material you will use, it will insulate things in a different way, which will impact the heat within the house.
Okay, so yeah, construction materials definitely something to consider. Now, Antonia, I guess your interest in this is kind of similar to mine because you're an energy manager, which means you essentially tell companies how to be more efficient about energy use. But I guess you're also interested in making buildings more efficient as well.
Yes, I am. The thing is, I don't often see new buildings. I often see buildings in existence. So we have to just work with what we have. So it means I don't get to read too much about this for work, but I'd still like to know what have we found and what can we learn from other countries.
Yeah, I agree. I mean, we have a lot of old houses here in particular. I don't think I've lived in anything that was built less than about 50 years ago. So they weren't insulated at all originally. So there's a lot of retrofitting going on.
And there was a big push for that, with government incentives for getting people to insulate the houses if it was so bad.
Yes, and I can see the sense in that because you're essentially leaking a lot of heat into the environment that you don't necessarily need to. But I guess in other climates, there are other considerations. So for one of the examples that I'd seen on my news feed was about constructions in the Caribbean. Obviously, it's a lot hotter there than it is here in the UK. They were building houses out of traditional clay rather than concrete because it works better in the hot climate. And they were also making some other climate adaptations that work with the local environment. I wonder, could we use some of that in the UK given that it's getting hotter here?
Yeah, that was an interesting idea because a lot of our construction is out of concrete and why I wanted to ask Raider about it. But I feel funny about it being made out of clay because I feel like there was a nursery rhyme which told us to not build stuff out of clay because it would just wash away.
I mean, you get clay pots that they hold water, but they've been fired, right? So I guess, would you need to somehow bake your house to make it watertight? I guess you cover it in something like a lime render, probably. Make more sense, wouldn't it? Rueda, are we just talking utter craziness?
What I was thinking of is actually making clay blocks rather than concrete blocks, and if we use those, they might not wash away. I have quite a very similar idea if we used it in kind of covering building. I think that might wash away if we used it in a similar way, because what we need is to think about, can we actually amend this to fit the climate here? Because the UK weather is quite rainy, even though it's getting hotter. That does not take the rain away. And I know there's lots of companies are starting up. One of them is called Q-Bricks that uses a lot of recycled material, and also they do not use heat to produce their bricks, which means it's quite very environmentally friendly.
What do they do instead?
Press it.
Press it.
Yeah, so it would be very dense. They don't tell you exactly how they make it, right? Because otherwise we would steal their thunder.
This sounds like a materials science question to me, though, because either heating it or compressing it will change the crystal structure of that clay. This is me going way past the engineering.
Yeah, but yeah, that's a good way to think about it. If we think of history and like ancient building, before they figure out if they burn it, it will get stronger, they would just dry it in the sun.
I presume putting it in a fire actually makes it a different material.
Yeah, that's a good point, and it would change the characteristic as well in terms of porosity and such.
This was the thing about the Caribbean example that I'd read about, that it was the traditional building technique. So where they've favoured trendy sort of North American style glass and concrete structures. This is a more usual way for making buildings in that area.
And it works better for their environment.
That's what the news article said, yeah. So when Rwayda mentioned that it's porous compared to concrete, it means that water can evaporate from it more easily, which draws heat away, kind of like someone sweating, I guess. Sweaty buildings is what we're going for here.
Sweaty buildings.
Yeah, also like if it's porous, like when the warm air comes and it already have evaporation, the air will get cooler going in because of the water. That's one of the things about evaporative cooling techniques.
Oh, okay. So I guess does that mean it needs to be kind of breezy as well?
Yes, it needs to be breezy.
Yeah, because I've heard evaporative cooling doesn't work so well in places like the UK because it's humid. And so there can be kind of too much moisture in the air, and then you can't actually sweat. So that's what happens in like hot, humid climates, especially. So maybe the Caribbean's, even though it's surrounded by loads of water, maybe it's breezy enough.
The other question is, can we make some sort of brick or a building material using clay that fits the UK climate with this moisture?
Yeah, I have heard, because I watch a lot of Grand Designs, which is a British TV programme about people that build all these like really wild and wonderful housing structures because they want to live in them. So they've got too much money, it sounds like.
Well, I suppose they have enough money to also try these techniques because I guess there will be less people who do it, so it'll be more expensive.
Yeah, and one of the techniques some people use is, again, it's a traditional technique in the UK from predating modern times, I guess, where they use clay mixed with straw, and it's called cob, and the straw gives it a lot of strength, and it seemed like it was reasonably water resistant.
Okay. I guess it's like reinforcing something with like fiberglass or what's the thing you'd like put sort of like plaster and then
Oh, like horsehair or something.
yeah, or like the more modern one which would be like some sort of mesh material and then you put plaster over it.
Yeah, I did wonder though, because if this was a traditional building technique in the UK and we don't use it that much anymore, it would seem, was it really that effective to begin with, or did it require a lot of maintenance? Going back to Antonia's point about would this really work in the UK?
Wonder what you do to maintain it is the other question. That's what I'm thinking about now.
Yeah, I'm still going back to my idea of you either render it or you keep fixing cracks as they appear. Or maybe you just accept that it'll only last like 2 years and you'll have to keep rebuilding your house. I just don't know.
That would be awful. But maybe that does mean we wouldn't be living with such old, outdated buildings if we were constantly renewing them. We would actually go, oh, well, might as well use this latest technique or technology.
And it still doesn't really get around my original point of if it's getting hotter in the UK, can we use clay to make cooler buildings? This is just creating a different problem entirely.
Yeah, maybe we'd have to combine it maybe with other techniques like ventilation.
And that's something I think is quite a weakness for civil engineers because ventilation is kind of based on aerodynamics, isn't it?
And we did have traditionally breezy, drafty houses way back when in the UK, didn't we? Because you'd have like a fireplace burning coal or wood and you'd have air drawing up through your floorboards. And we don't want that now because we get really cold in winter. So everything needs to be super insulated but not keep the heat in summer. So I guess maybe applying something from the Caribbean where it may be hot all years round would only fix half the problem.
Yeah. I think that would create a winter problem, isn't it?
Yeah.
You'll have a too cold house that you can't afford to heat.
Potentially, yeah. But then, and I read another article that was along similar lines to the idea of keeping a house cool, but this one was in India rather than the Caribbean. They were using thermodynamic principles and natural wind direction to keep a house cool. And I think they saw a drop of 10 degrees Celsius inside without any sort of mechanical ventilation or any other means of cooling.
I mean, that's very impressive.
Yeah, it sounded like it would probably be reasonably comfortable to me. So although it'd still be like 29 degrees Celsius, which is still kind of warm, I've definitely survived in hot countries with room temperatures like that, as long as it's not too humid.
Yeah, the question is, can you sleep with that temperature?
I think if I had a fan, I'd be fine. But that's just me, right? I'm one person.
I suppose that's a form of mechanical ventilation or mechanical movement of air.
This is true. But I was still encouraged by, so they're not using air conditioning.
No.
They're just using natural physics that's already there to keep a building cool.
Yes, it's quite a smart way to do it.
Yeah, so I had a look because it mentioned it was some thermodynamics and it was based on the Venturi effect, which took me back to thinking about fluid dynamics.
Oh, as your chemical engineering kicks in.
Yes, and the Bernoulli equation and the ideal gas law. So a combination of the two. And it's so counterintuitive. But I saw a good example to explain it, which is if you blow air to your finger, it feels cool.
Yeah, I can see that.
Now, this is where I'm like, it doesn't quite work with this mouth example, but when air sort of passes through a narrower space, assuming it's at a constant volume, so you've got the same amount of air but going through a smaller gap, then it has to go faster through that smaller gap, and therefore it changes pressure and the temperature drops.
Are they saying like if you try and blow air across your hand with your mouth wide open, the same volume of air is going through quite a big gap and it feels warm, which it does. But then if you purse your lips and kind of whistle
Yes.
or make a whistling shape, it's a lot cooler.
Yes.
I would say because it's probably got the same amount of energy embodied, that I guess I can kind of see without doing any maths how that would sort of suck energy out of an environment because you've got the same energy in a smaller volume. Does that make sense?
Yeah, you do have to keep a lot of the variables constant apart from the opening in which the air is traveling through.
Yeah.
And that's how you get that temperature drop.
Oh, I never thought of that. That's very smart. It's a very simple concept, but it's quite smart because you don't usually think about it.
No, the example in that article almost was like a wall full of holes, wasn't it? It was a very holy wall, which I guess you can make arty and decorative rather than looking like Swiss cheese. It's like a passive cooling technology, but also could be arty. People might like that rather than it looking like another sort of bootleg version, which I've seen for a natural air conditioning unit is someone's got like a wall, and do you know the tops of like 2 litre plastic bottles? They've just put a bunch of those into the wall so that it goes through the neck where the cap would have been, and they take the cap off.
Okay. Yeah, that just looks like you're building stuff out of rubbish. Although that plastic is still quite valuable, I'm not sure I'd want to use it as a building material you can see.
It might be a good temporary solution, but
Yeah.
definitely not going to last you that long.
Well, it's plastic. It'll last for quite a long time, won't it?
I don't know, it would just kind of get gross.
You can clean stuff if you can be bothered, I suppose.
It would just be so fiddly.
Yeah, well,
Supposedly it degrades in UV.
fair enough. I will say, when I looked at pictures of this building in India, I didn't get a really good sense for the aesthetics of it, like how nice it would be. It's got really thick concrete walls, and it did kind of give me the impression that it's basically just like this really big concrete bunker that's ventilated so it doesn't keep the heat in.
Yeah.
But I feel like I'm dissing the architect that came up with it. He's obviously really smart to have thought, we'll use thermodynamics here. And it may well look really nice. I just, from pictures, didn't get much of a sense.
The concepts there, maybe someone else in grand design can pick it up. But I thought this is interesting because you kind of get like between buildings, you kind of experience that wind tunnel effect. You'd feel it's a bit breezier when there's a whole line of buildings. So if you could like utilize the natural wind direction, use those little gaps in a wall, and then you could get some natural cooling.
This is true, yeah. See, I wondered if we needed to be cooled in summer but warmer in winter, so not cooled. Could you manufacture some sort of almost shutter type things that make a small gap in summer, but then they can peel back in winter?
Yeah.
So then you don't get the cooling effect?
We need to get in the civil engineering degree and construction degree generally more thermodynamics so people could able to design differently to ventilate and use all these concepts in building.
That's a good point. I've not formally been taught any engineering, but I always get the impression that there's this idea that it's about doing things that defy expectations and are like really sort of brute force, like, you know, really tall buildings, like the Burj Khalifa that's built on sand. That you would think, why on earth would you build the tallest building in the world on sand? But they did it. Or really big bridges, that sort of thing. It's like this almost brute strength style. We're just going to do it and we don't care how unfeasible it should be. But this is the opposite. This is like saying, let's work with what's already there. Let's be smarter about this rather than just brute forcing something.
I think sometimes it's kind of like challenging nature, right? That's what they do. They challenge nature to build whatever they want. And what you're talking about is employing nature to make it easier for us to coexist, really.
Yes, it's a very good way of putting it.
I'm trying to find some good words here.
Yeah. I guess it's like we kind of got so much abundance in some places that you just do what you want, whereas when you have less, you kind of have to work with what you've got.
More with less, isn't it? Sometimes.
Yeah.
I mean, I will say it feels like in the UK we're not necessarily making use of natural processes, but just sticking with this
Mm.
kind of brute force style approach. Like Victorians, we've got a lot of coal, let's burn it all.
Yes, that was an era, wasn't it? The Industrial Revolution.
It's like each era had something that they decided to do a lot with, like when they found the lead, and they're like, let's just put lead everywhere. And now, like, even today, some old churches will still have the water system that is lead. Sometimes they find they have forgotten something, and it's became toxic now. So
Oh, yeah, my old house, it was built in the 1911, I think. That had lead piping, and I'd read that it was fine because it has this layer of stuff on it that protects you from the lead. So just if as long as no one messed with the water chemistry going to my house, it was fine.
but once that layer is off, because like they found some layers off in a nearby church, they had to take all the pipes and test everybody to make sure they're safe. But like this is my point is like we get this era of finding something. Oh, this is the best thing, so let's just all use it.
Like asbestos.
Yeah, that's what I was thinking. I'm realizing it's actually not that great.
Like how fire resistant asbestos was until we realized, oh, this gets into our lungs and causes respiratory issues and cancer. Ah, don't touch it now.
Which means it's just like working with nature is the best scenario rather than challenging nature just to make it bigger and better.
And I guess that's where things like heat pumps as a way of heating water and air come in, because they're not necessarily new technology, but they've not really been embraced in the UK as a method for heating your home.
No, but it's really clever considering it takes use of thermodynamics and you get more units of heat than you put in units of electricity, which sounds like magic, you know?
It does. But it's not, it's physics.
Yeah, the energy balance doesn't at first make sense unless you know about thermodynamics and the refrigeration and heat pump cycle.
But then it sounds like there's other sort of less energy efficient technology that's a lot simpler to install, combi boilers that burn gas. We've just had a heat pump fitted, and it did take quite a lot of effort to replace the old combi boiler, and requires more space, and was really disruptive. But it means we now have a fossil fuel free home.
I mean, I remember sort of just as I was growing up in the 90s, people were starting to remove hot water tanks and put in combi boilers because they were more reliable and it gave you instant heat. And now, sort of 30 years later, we're sort of switching back because we actually realize hot water tanks are useful and maybe we have to get back to well, we have to get used to not having heat instantly and just having like a steady amount of heat, and then your heat pump can be smaller.
Yeah, I guess there's also the idea that because we've got more renewables supplying electricity to the grid now, which is slightly more intermittent, you can help balance that out by taking some of the load when it's needed. So you'd have your heat pump heating up your hot water tank when there's a lot of energy being produced from renewables. So maybe that's another reason for going for it now as well.
Yeah, it's like the hot water tanks are a form of energy storage.
Yeah.
Another like historic thing we would have more are awnings. Imagine you could just, again, this is going back to keeping us cool. It doesn't help us when it's cold, but if we could put more shade over our houses, then the sun's not hitting our windows and we're not getting that kind of solar gain or greenhouse effect, then you won't need to cool your house as much.
Yes. I read very briefly an article about some people in Australia who had done this with trees.
Oh,
And they didn't need any air conditioning in summer, which I thought was impressive for Australia.
Wow,
'Cause
yeah.
it gets
yeah.
really hot.
They do say this, like gardens with grass rather than artificial lawn stay cooler. Even that low-lying plant, not even just trees, but I think something about the managing the moisture helps.
Yeah. So, Rwayda, you're a lecturer in civil engineering. Can you see yourself having like little asides in your lectures to your students saying, by the way, guys, plant some trees when you're designing your building?
Well, I think that's something we always encourage, right? Because there's the green roof concept and you have the roof gardens and all of that. So we actually talk about this all the time. It's an important one. I think it's just never thought of the cooling aspect of it, right? You could just
Mm.
link it to what you're already saying in terms of green roofs and all the other things that we do for environment. Is actually not only for environment, it's for us too. We could use it to cool our houses.
Do you think it's easy to put on green roofs and living walls, or do you think you have to really plan that in to when you do the design?
I think what you need is to make sure that you have a structural engineer assessment to your roof to see if would it be able to hold the extra weight. Because
Mm.
if it can, why not? Because everybody now is adding the solar panels on their roofs. You could kind of calculate how much weight they are and see if your roof is strong enough to carry this or not. And the answer might be yes, or with some reinforcement. Or you even might say, well, that part of the roof is fine, but that part isn't. So it's just an assessment that the structural engineer do, and you'll be good.
So, going back to my whole grand designs thing, a lot of people build, or some people I should say, that I would like to do that if I had enough money. They build passive houses. They're really well insulated and they're airtight with like membranes, and they have mechanical ventilation so that they don't necessarily need any or a lot of heating. They recover all the heat in the air rather than pumping it out.
That would be great.
Yeah, but it's always people that have a lot of money, which bothers me. That means not everyone can do it. But do you think that'll be the future where it's just standard that passive houses are built or not because energy companies still need to make money? It's a question for both of you there.
I think that's a more political question than a sciencey question, isn't it? I would say if we will be able to sway the energy company to invest in the other technologies, then they will make their profit there, then you can switch to these and make them more affordable. That's my opinion, at least. What do you think, Antonia?
Whew. I mean, the whole green transition, what we call like trying to reach net zero, people are always concerned about expertise and are there enough people to actually do it? And say like gas engineers will have to retrain to do stuff related to new heat pump or other technologies. I think, yeah, you got to kind of be adaptable.
Yeah, I agree. Having listened to you both weigh in on this, I can see that energy companies might diversify a bit to also do sort of passive housing technologies. And then we'll just kind of, if I could build a smart home that has a lot of electrical appliances in it, there'll still be a need to supply electricity.
Yeah, and even thinking about the transition, we're looking at electric cars now. Oil companies just had to go with the wave.
Yeah.
Car companies had to go with the waves. Like most of the manufacturers now, the big ones started to do hybrid and electric cars. So I think if the people decide to go a certain way, other things will have to at least consider diversifying.
Or even if people start installing their own energy generation, like solar panels, then electricity companies won't have a market unless they're just supplying the night. So they have to look at different technologies and yeah, maybe go into insulation. And then also if the grid is more variable, then that's also more risk to manage because then you kind of have spikes in energy, although this is more of a national grid issue than it is an energy company issue.
So what we're saying is it's a time of change, really. So maybe my idea of taking building principles from India and the Caribbean could be embraced in that case.
I think
Yeah.
it could be with the right adaptations.
Or Australia.
Well, there's probably a lot we could learn from other nations. I mean, they're just like 3 examples that I came across on my news feed. But I mean, you hear that Europe is way ahead of us on like making houses and buildings more energy efficient, and it gets a lot colder in certain European regions in winter and a lot hotter in the summer. So they've got more extremes to deal with than we do.
I think that might be partly, I don't want to say political, but maybe societal, because there's kind of like the history of people owning land, becoming landlords, owning a house, whereas I think in say like Germany, the rental market is a lot bigger and people don't own as much houses. And I think of a colleague who was looking at Spain, and people don't really buy new furniture, they just leave furniture behind. It feels like we've kept really old houses, but we keep buying new kind of flimsy furniture in the UK.
which I dislike because I hold on to furniture for ages. I don't really want it to fall apart. Once I've bought it, that's it. That's done. I can repaint it. That's as much as my design tastes extend to. I feel like we're just kind of rambling a bit now. We've kind of gone from talking about fundamental engineering and scientific principles to my furniture buying choices, sociology and politics. So, as I said, perhaps we could maybe take a leaf out of architects and engineers from the Caribbean or from India and design some more intelligent housing in the UK that is actually more adaptable for our changing climate. So, thank you for listening, and we'll see you next time.
Bye.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.